Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Maths. And without any further ado, let's look at these questions that we have here. Okay, so we are given a question 7. It says, in the figure below, OA is a vertical tower, and the points K and T are in the same horizontal plane as A, the foot of the tower. AOK is X, and then KAT is 90 degrees plus X, then KTA is 2X, and OK is 2 units. So everything has been indicated here on the diagram. Then 7.1, I want you to read 7.1 carefully there. So it's hinting to the same strategy that I've been talking about, that you need to express this in terms of the common side. So look at this, express AK, express what? AK in terms of a trigonometric function value of X in two different ways. And hence or otherwise determine the length of KT. Now, I want you to look at this. AK exists in this triangle, which is, we can name it OKA. So AK, we can see it exists in this triangle, but AK again exists in this other triangle here, which is KAT. Right. Remember, the strategy that I gave you is that always look for that common side and try to express that common side as the subject of the formula, which in 7.1, now they're hinting to that strategy to tell you that that is the strategy that works. That's what they want you to do here. Right. So now this is what we are going to do in tackling this question. Remember, we are supposed to express this express AK in terms of the trigonometric function of value X in two different ways. So that means in both these equations or triangles, we're going to be expressing AK as the subject of the formula. So this is how we go about it. This is a right angle triangle. So that means here, SOHCAHTOA applies. So in this triangle, which is in triangle what? In triangle OKA, we want to apply SOHCAHTOA. So our AK here, in reference to the angle that we are given X here, we can see that it is the opposite side. And then the 2 here is a hypotenuse side, right? So we have opposite and hypotenuse. So that means the trig ratio that would work is sine. So this is sine X is equals to, our opposite is AK, but our hypotenuse is 2. Now, to make AK the subject of the formula, this is AK is equals to 2 sine X. Now, we're going to say this is our equation number 1. But then remember, we must express in two different ways. So let's go to a triangle KAT. So we're going to say in triangle KAT, look at this now. This is a non-right angle triangle. So obviously, we need to apply the sine rule, right? But then remember, we are still making AK the subject of the formula. So we should take this angle here and that side AK. Then we are given this angle here, 90 plus X. So we should take it with the corresponding side here, which is KT, right? Okay, so which is the length that we are trying to determine after all. Then, okay, so if we say sine 2X over the side that is opposite that angle, which is AK, and then is equals to what? Sine 90 plus X over what? The side that is opposite that is KT. Okay, so if we cross multiply here, this is KT multiplied by sine 2X is equals to what? AK, but then remember, this is a cofunction. So it changes to what? Cos X, right? But then remember, we are supposed to make AK here the subject of the formula. We're trying to express AK, right? Then we can divide both sides by what? By this cos X. Divide both sides by this cos X. Now AK is equals to KT. But then remember, this is a double angle, so it needs to be what? 2 sine x and then cos x over what? Cos x. Now this and this can cancel out. So our AK is equals to KT and then 2 sine x, right? So let's say this is equation number 2. Now we have done this. We have expressed AK in terms of the trigonometric function of value x in 2 different ways. So it can be expressed in this way, and it can also be expressed in this way. Now they're saying, and hence or otherwise determine the length of KT. Now we are on calculating the length of KT. So what are we supposed to do after here? Now this is the point where now we equate the 2 equations. So we're going to say equate equation 1 and equation 2. Since both these equations are expressed in terms of AK being the subject of the formula. So this will be 2 sine x is equals to what? KT and then 2 sine x. Now at this point, we can see that we are supposed to divide both sides by 2 sine x. Divide both sides by 2 sine x. Now here, cancel. If they divide here, they're going to leave 1, right? So 2 sine x divided by 2 sine x is equal to 1. So that means KT is 1 unit. And then just like that, we've determined the length of KT. Right. Then let's proceed to 7.2. So 7.2 is saying show that AT is cos 3x over cos x. Now, how did they find that? Now, this is AT. If we are still supposed to use the sine rule here, we need to find the angle here that is opposite side AT. But then here we have 90 plus x and 2x. So in order to find this angle here, we know that we will need to say 180 minus 90 plus x, and then also minus what? 2x. So if we say 180 minus 90, that gives us 90. If we say negative minus x, that's negative x minus 2x. So this will give us 90 minus 3x. So the angle in here gives us 90 minus 3x, right? So this is the angle for AKT. AKT is 90 minus 3x. So let's use the sine rule now. Remember, we've already calculated KT, and then we found that it is 1. So we can use the sine rule and say for 7.2, we are using this triangle KAT. So in triangle KAT, for the sine rule, we're going to say sine 90 plus x. But then remember, our KT is 1, and then is equals to what? This is going to be sine 90 minus 3x over what? Over AT. But then remember, this is a cofunction here, so it changes to what? Cos x, right? And then if we cross multiply it with the AT, then we have AT cos x. And then here, this changes to a cofunction also, which is what? Cos 3x. Now, to make AT the subject of the formula, let's divide both sides by cos x. Now, as we can see now, AT is equals to cos 3x over cos x, right? And that's how we have it now. Okay, now let's go to 7.3. Simplify cos 3x over cos x to a trigonometric function of sine x. Okay, now let's clear off the space for that. Okay, 7.3, we have cos 3x over cos x. So we are supposed to express this to a trigonometric function of sine x. Okay, let's start. We can try to write cos 3x in terms of cos 2x plus x. So I'm trying to use that so that eventually maybe it will cancel off with this cos x. And then this is a compound angle. So it's supposed to go cos 2x cos x. But then we know the compound angle of a cos changes the sign. So now it needs to be negative sine 2x and then sine x, then still over cos x. Now, if we can try to just, let's continue writing this one, cos x. Now we know that the double angle for sine always breaks down to 2 sine x, cos x, right? And then multiplied by sine x. Then that will be over cos x. Now the sine x and the sine x, if they multiply, they will give you sine squared x. So now that we have got the hint from this side here, let's try to break down the cos 2x to this one here, which is 2 sine, 1 minus 2 sine squared x, right? So let's use this one because we can see that they're trying to make us simplify this to a trigonometric function of sine x. So it is best that we break this one in terms of the sign. So this is 1 minus 2 sine squared x and then times cos x. So which will give us this side 2 sine squared x and then cos x, right? Over what? Over cos x. Now you see if we take the cos x multiplied by 1, that's cos x. But if we take the cos x multiplied by this, it gives us 2 sine squared x cos x minus 2 sine squared x cos x. Then over what? Over the cos x. And now these ones are like terms and then they're going in the same direction. So they need to be cos x minus 4 sine squared x. And then we have cos x over what? Over cos x. Now at this point here, we can then try to factor out. So let's factor out the common factor. So to factor out our common factor in the numerator here, we can see our common factor is cos x. So this will be cos x and then 1 minus 4 sine squared x. So you see what happened here? Factoring out the cos x. If we factor out the cos x here, we are only left with 1. But if we factor out the cos x from here, we are left with this 4 sine squared x. So this is what happened here. But then this needs to be over what? The cos x. So this is what I've been trying to do. So cancel out, cancel out. So now I'm left with what? 1 minus 4 sine squared x. I wish there was just an easier way to do it, to just cut this one to at least 4 steps. I don't know how, but then if you do manage to do it, you can do it and send to me. So that's how we were supposed to approach this question, guys, for a total of 4 marks, and then all the question for a total of 11 marks. And then we have came to the end of the lesson. With all that being said, please press the thumbs up button if you've enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.